Today we're going to talk about operations with algebraic expressions. So to start, we're going to talk about what some algebraic expressions look like. We'll begin by talking about like terms. So as you can see, we have a bunch of algebraic expressions here that all have variables, and some of the variables have exponents. Like terms have the exact same variables with the exact same exponents. So the first algebraic expression we see is 3xy. So it has an x and it has a y, and neither x nor y have an exponent. So as you can see over here, we have negative 2xy. They are like terms. They both have an x, they both have a y, and they don't have exponents. The next one we see is the 3x squared y. So we need to find another term that has an x and a y, but the x is squared. The 4x squared y. 5xy squared, so anything that would be like that would have an x and a y squared. The negative 7xy squared. And finally, we have negative 9x squared y squared, so a like term would have an x squared and a y squared. When you combine like terms, you just add them or subtract them just like you would regular numbers. 3 and 4, 3 plus 4 is 7. 3x and 4x, 3x plus 4x is 7x. So you treat the variables with the same exponents and the same variables as almost like they're apples. If you have 3 apples and 4 apples, put them together, you have 7 apples. Oranges, if you have 6 oranges and I take away 2 oranges, then you have 4 oranges. So you just add and subtract the like terms as normal. The variables and the exponents are not affected with just combining using addition and subtraction. So let's do some examples. So here we have two big algebraic expressions being added together. 3ab squared minus 4a squared b plus 5ab plus 7a squared b minus 3ab plus 6ab cubed. So I'm adding these two algebraic expressions completely. When you have a big set of parentheses, you need to make sure that if there's anything that needs to be distributed, you take care of that first. There's nothing to be distributed here. There's nothing to be distributed there. So you can drop the parentheses and you have 3ab squared minus 4a squared b plus 5ab plus 7a squared b minus 3ab plus 6ab cubed. So now you're going to look for like terms. Like terms have the same variables with the same exponents. 3a squared b. There's no other term like it, so that's not going to get combined. It's going to stay. Negative 4a squared b. Another a squared b is right here. Negative 4 plus 7 would give us 3. ab, we have 5ab. Take away 3ab. Put that together, you have 2ab. And then there's no other ab cubed term, so the 6ab cubed stays the same. Looking at the end, there are no other like terms, so that is your simplified answer. Now, when you take two big algebraic expressions and you subtract them, this is very important. You're subtracting this entire group here, which means you need to subtract each of the pieces. So you need to subtract the 7a squared b, you need to subtract the negative 3ab, and you need to subtract the 6ab cubed. So you need to distribute that negative. So the negatives become, or the positives become negatives and the negatives become positives. And then you combine your like terms like we did before. And notice you get a different answer than we got up here when we added the two together completely. Now let's talk a little bit more about that distributive property. When you have something lingering outside the parentheses, like 2 times x minus 7, you're going to distribute that 2. When you distribute, you need to be fair. Everybody that you're distributing to needs to get that number or variable or whatever it is you're distributing. You've got to be fair. So when we multiply this 2 in, we're going to multiply everybody in this group by the 2 to get 2x minus 14. Now, when you distribute, sometimes you distribute numbers or sometimes you distribute algebraic expressions like 3x squared. This is where our properties from previous lessons are going to come in to play. So the 3x squared we're going to distribute to everybody in here. 3x squared times 2x squared, multiply your numbers, 3 times 2 gives you 6. Multiply your variables, x squared times x squared becomes x to the 4th. Like bases being multiplied, we add the exponents. Distribute the 3 to the negative x, that's just going to be a negative 3. X squared times x becomes an x cubed. And then the 3 times negative 5 gives you the negative 15, and the x squared will tag along. Take a quick look. There are no like terms. That is your simplified answer. Now we're going to talk about the situation where you have an algebraic expression that has addition and subtraction in it being multiplied to another algebraic expression with addition or subtraction. What you need to do is every term from the first group needs to be distributed to every term in the second group. Everybody gets everything. You need to be fair. So this x, you're going to take x and multiply it to everybody in the second group. X to the 3x, x to the minus 4. Then you do the next term, 2. 2 needs to get multiplied to everybody in there. 2 times the 3x, 2 times the negative 4. So that gives us 3x squared minus 4x plus 6x minus 8. And then we look to see if we have any like terms. Negative 4x plus 6x gives us that 2x. Let's do some more examples with the distributive property. Here's one that's a little bit bigger. You're going to follow the same rule. Every term in the first group gets multiplied to every term in the second group. So we'll take the 2x times 3x to the 4th, the 2x times the minus 4x cubed, the 2x times the negative 12x, and the 2x times the 2. Then you'll do the negative 5. Negative 5 times 3x to the 4th, negative 5 times negative 4x cubed, negative 5 times negative 12x, and negative 5 times the positive 2. And so when you do that, you get this big, long algebraic expression when you multiply the 2 and you multiply the negative 5 to everybody. Then you look through, you find your like terms. I've got a negative 8 to the 4th and a negative 15x to the 4th. And what else? I've got a negative 4x and a 60x. So once you combine all your like terms, you get a final answer of 6x to the 5th minus 23x to the 4th plus 20x cubed minus 24x squared plus 56x minus 10. No other like terms, so you're done. One more thing that we need to be very conscientious of. One of the things we talked about with the properties of exponents was that if you had addition or subtraction inside the parentheses, you could not distribute the exponent. Here we have 3x minus 2. We have subtraction inside the parenthesis. You cannot distribute the exponent. But what does it mean to square something? You times it to itself. So 3x minus 2 squared is 3x minus 2 times 3x minus 2. And then you just distribute like we were before. Every term in the first group goes to every term in the second group. Distribute the 3x, distribute the negative 2, and you get 9x squared minus 6x plus 4. Combine your like terms for a final answer of 9x squared minus 12x plus 4. So now we've done some of the basic distribution problems. Try the examples that are on the back of the sheet.